All right, welcome to our final report presentation of our solid waste management project about utilizing coffee grounds waste for clothing material. Okay, so regarding the design details of our polio vessel, we got two vessels over here. The first vessel on the left is where the acid liquefaction reaction is happen, and the one on the right is where we actually obtain the polyurethane mix, or either polyurethane or polyester. Uh, these two vessels is connected with a single pump to pump out the polio from the first vessel to the second vessel to continue the process. Also, do keep in mind that this is just a prototype, so it's quite a small device. Only it doesn't exceed 60 centimeters squared, so it's not ready for industrial process yet. I we actually base this vessel on the PAR model 6640, I think. According to the research that we found on ResearchGate by Nuno Gama et al. Okay, so first question regarding the chemical reaction within the first polio vessel. Okay, regarding the reaction in the first vessel, because we do this project by literature study, we can't actually show the actual chemical molecular equations, but because we cannot find that on the research paper that we found, but basically these spent coffee grounds are mixed with polyethylene glycol as solvent and sulfuric acid as catalyst in vessel 1, and while this mixture is stirred and heated for a specific time and temperature, and that specific time is for around about, if I can just find it, it'll be for around about 60 to 80 minutes and in a temperature of 150 to 170 degrees centigrade. And after that, we can obtain the polyols, and those polyols will be pumped to the second vessel, where we will continue the process to actually obtain the polyurethane that we can use for clothing materials like shoe soles and polyester for the clothing yarns. And for the second question, oh yeah, also because we based it on the PAR reactor vessel, the PAR reactor vessel needs 115 volts electrical supply for it to function, and because we have two vessels here, I'm going to assume that we're going to have to double it to 230 volts. On to the second question, which will be answered by my colleagues.
Hello there. My name is Akbar. Regarding the second questions about the heating process and the pumping process. The heating process actually can be done with the use of the hot water or with the heater itself within a certain amount of temperature. And with the pumping process, theoretically, it can be done with a different pressure through the reaction process. And since the pressure on the vessel 1 is greater than vessel 2, a hole relieves the pressure in the vessel 1. Thus, the fluid later flow into the second vessel.
Also, I would like to add that what that means is that yes, we have these holes to relieve excess pressure, but because because due to the reaction that's happening in the first vessel, the pressure will still be greater than the one in the second vessel, where it will still be empty. So theoretically the polyol will by itself transfer to the second vessel due to the difference of pressures. But in case that didn't work, that will mean that we will need an actual pumping device that we don't add in our prototype. Okay, on to the third and final question.
Okay, so in regards to the third question, uh, the thickness of the pressure vessel is based, we based it on the scale model, which is, has a thickness of around like 150 millimeters. And the material used for the pressure vessel is stainless steel. Taking into account the vessel must be able to withstand high pressures because of the chemical reactions inside. And also taking into account the pressure vessel must able to withstand the chemical reaction, the acids from the chemical reactions. So that's why we chose stainless steel, because it doesn't corrode when it is exposed to the chemicals.
Yeah, of course, dealing with acids, acid corrosion is one of the main thing that we have to consider. And despite that, 15 millimeters is quite a big safety margin that we took. So in actuality, we might not need that big of a wall for the vessels. All right, I guess that's the end of our presentation. Thank you for watching.